Hello, everyone. I'm Kartika MS, Assistant Manager at EY. I'm delighted to host today's session in collaboration with our speaker, Giulia. Thank you all for joining today's session. I greatly appreciate your valuable time and participation. The entire session will be recorded and uploaded in YouTube in VI tutorial, WaiTUTORIAL. WaiTUTORIal is an online educational initiative organized by women in AI, falling under education category. It features experts who give 30 minutes presentations on topic that benefits the audience, ranging from beginners to advanced level. The presentations usually demonstrate a small concepts or tool or applications. Namarita Roy leads the initiative with Na and myself as a co-lead. The education wing also hosts WAI practice, a sessions co-lead by Luciana and Meghna Rathi. If any of you are interested in presenting at WaiTUTORIAL, please take a moment to complete the speaker's form, which will be shared shortly in the chat box. Your participation as a speaker would be greatly appreciated. Additionally, I'll be also sharing a feedback form at the end of the sessions. Your valuable feedback will be highly appreciated as it helps us to understand and deliver even better session in the future. Without further delay, I would like to introduce our speaker for today's session, Giulia Osti. Giulia is a D-Real SFI funded PhD student at the University of Dublin, School of Information and Communication Studies. A former archaeologist with a long-term experience in data science, web, and visual design, she is also now entering information studies and researching artificial intelligence in context of digital preservations. Once again, thanks for joining, everyone. And I would also like to express my sincere thanks to Giulia for accepting our invitations and also being here with us today.
Nice to you.
Now I kindly request Giulia to take the lead by sharing your screen.
Absolutely. Just give me a second. The time of sharing the screen. Okay. Okay. There we go. So now you should see my screen and the presentation in now. Can you see that?
Yeah.
Perfect. Cool. So thank you very much, Kartika, for the introduction. Was pretty accurate. So basically, the left-hand side of this slide is completely useless in these moments, but it makes sense actually. And I just wanted to say that the reason why I remarked that I'm a former archaeologist is just to prompt you that you're here and participating to this kind of tutorial, that to try to explore areas you're interested in. Doesn't matter really your technical expertise, you can always learn, especially when it comes to data science. In truth, I had then, after my formation in archaeology, I really had the opportunity, the chance to delve a bit into bioinformatics. That's the reason why I proposed decision trees as a topic. So anyway, for any reason, if you want to contact me just to chat about any sort of nerd thing regarding ML or computer vision, feel free to ping me or just, of course, to ask me about more resources. So today's takeaways are: understand the limitations and potential of the decision trees, become familiar with the key concepts, some of them, not all the details specifically connected towards, let's say, to the application in Python, and the mechanisms, of course, how it gets generated and so on. Learn how to build and evaluate the decision tree in Python and scikit-learn, which is a very, very, very incredible suite to work with. Machine learning offers so many options, so highly recommended, although it's not the best, in my opinion, when it comes to decision trees, but still, it's a good approach to get started with that. Last but not least, no alternative tools for tree building and visualization, because there are other options. So what are decision trees? Well, let's say that they kind of, the term decision trees tells you all. And the funny stuff is that the terminology related to this kind of ML algorithms, which are normally defined non-parametric, but let's say the broad name for which they go is CART, classification and regression trees. So yeah, they support even multi-class classification and regression tasks. So you can get more answers because they handle more variables. So if you're trying to do a regression, but not with just a couple of variables, well, that might be your choice. So these allow to solve decision problems, or better, sometimes they are more useful when it comes to exploratory tasks, as they categorize the object you're analyzing according to specific decision features. Okay, perfect. And use cases. So you can use that if you're into business, any sort of business, for product analysis. If you have the characteristics of that object, you can analyze, for example, the behavior sometimes of, depending on sales, the behavior of people choosing that. Maybe there is some clue in your data set. In botany, which is the context in which I learned how to work with decision trees. So actually, botanists use decision trees, or used, right now it's not that popular, but it was, to generate, it was called dichotomic or dichotomous keys. So a sort of decisions to determine which plant you were looking at. There are in fact these sort of keys, these books, which were used in the past, paper books, now are mostly digital, used to determine, according to the features, to the phonetic, the aspect of the plants, what was the family to which they were belonging, or the species. You could really handle the complexity with that tools. And of course, as I already told you, exploratory analysis, sometimes it's really useful. And that's, in my opinion, the best choice, because as you will see, there are several problems or caveats when it comes to these tools. So although they are highly visual, so you can see actually the results, it's not like other machine learning techniques in which you cannot really have any clear output until you get the accuracy and the metrics. Well, you can see, you can explain that it's a white box model, which is good. It requires sometimes almost zero data processing, because you don't really need to do a lot of work with transforming or putting the variables according, if you have numeric variables here already done, you just might have to convert categorical variables into ordinal variables, but that's another story I'm going to tell you very soon. And of course, they can handle it because of the fact that you can convert, they can handle either mixed data sets. So it could be categorical alongside numerals. That's very nice. So what's the issue? They tend to be sensitive to variance. So you can generate a very different tree if you just modify a few of the observations. So that's a problem, especially when you want to try to implement your training set. And really, they're extremely variable in the outputs. And that's the reason why they don't tolerate the variance. And so they tend to be very unstable. As I told you, pay attention to the categorical variables, and I will tell you why. And one tree does not make a forest. That's a kind of echoing to the random forest, which is a way nicer way to approach the system. There's no, the trees you generate with this tool, with this approach, the classification, and I'm not going to go with the regression because it could have been working for the variables I was using. Well, you will see. But the fact is that you might decide to get this tree, to get the output of this tree, and try to decide upon this only single output. You can validate that though, but it's always better not to have just one tree. You should have more trees, and that's the reason why when I approach this, I use Bayesian statistics, but that's another story. Anyway, it's still useful, depends really much on the way in which you work with that. So what are today's tools of the trade? Python. Well, I don't think I need to explain that, but anyway, that's the actually extremely popular language, which is used almost everywhere. It's a multi-purpose language, so you can really use that for whatever. I really use that for whatever, not just like even for web design. It's amazing with Django and other tools. Anyway, the scikit-learn suite that I mentioned before, which is very nice. Actually, I just included the main portal link and the documentation link, and Google Colab. So I prepared for you today a small Colab notebook. Actually, I don't know if you know that. Sometimes, yeah, sometimes I find people that never use that because maybe they were using Anaconda or Conda or Miniconda, whatever, or just specific suits like, I don't know, PyCharm or whatever. But this is the version which is free from Google. So you just need to get a Google account to access that. So it's extremely convenient. And our dataset, which is actually generated with the help of ChatGPT. Yeah, for fun, you know, I always like that. But why I am presenting to you alternatives to Python. So as I told you, scikit-learn, the classification decision trees algorithms are not the best ones to handle these kind of things. You will see why, because they normally support just binary choices. There are options that are not available. Let's say it's not very much flexible as other competitors. Namely, Weka, a very old-fashioned suite from, as you can see, the Waikato University from New Zealand, has been out there for ages, I think, 15 years, something like that. Still free, still fully interfaced, so you don't need to know how to code. You just can grab a manual, understand, or even the manual that I'm linking here for you, understand the concepts of the models behind that and all the options you can get. So you have a lot of applications of this suite. And just get started with that, avoiding any sort of coding. But if like me, you're a code-first person, well, you will go for RStudio. That's another old-fashioned language, but not so much old-fashioned IDE. So the integrated development environment that you can see here, it's amazing. I really like it. I will keep on using that, although, well, it supports Python, but I still use other tools to work with Python. Yeah, I confess. Anyway, the rpartplot package on CRAN is the one which allows you to work with decision trees, okay? So, juicy stuff. Okay, how does a decision tree looks alike? Well, if you just Google the term, you will find several examples that normally do not really make an immediate sense. I mean, like, they're so simple, extremely explainable, but very often you don't really reconnect what they mean when it comes to the significance of what you're looking at. Anyway, but the first thing you should start to do whenever you jump into those decision trees, just try to analyze the elements, because if you understand the symmetries behind that, it's very easy to understand how they work. And as a first very macroscopic level, you can grab really the meaning, let's say, of and the elements that allow this Boolean logic to work. You will see it's extremely simple, but having this affinity with machine learning means like that you have still a layer of complexity which derives from the practices of machine learning itself. So anyway, you have the root node, which is the part from which you originate the decision, and you have the ramifications, branches. You know, it's not really creative when it comes to that, and a set of decision chance nodes set. So you can see here just apple, but normally it gets really ramified. You have a lot of branches, okay? And at the very end of it, you find leaves, okay? Here you just have 3 levels. You might end up having n levels depending on the number of variables and the opportunities to split, okay? So this kind of pyramidal, let's say, structure, this hierarchy you have, is interpreted according to depth, which is one of the items you normally control when it comes to deciding how to handle this knowledge. Imagine that's allowing you to explain a bit complexity, which is something which is really valuable in nowadays world. Sometimes you need to classify stuff which is not really understandable because you have so many variables, so many features that you're completely overwhelmed. That poses a lot of challenges, but also it might be really easy to handle. So I placed here some words that are really meaningful. As I told you, I just told you about the depth, the root node levels, which could be several until you reach the very last level, the leaves. But there are other things which are essential, and I'm not going to cover them in detail today because it makes no sense for a very easy and sweet start. So pruning, which is gardening literally. So it's just like removing some nodes, because you might need to do that in order to remove a bit of entropy, as it will, they're kind of unstable, and which means like that. You also have to, and they're kind of simple algorithms, so sometimes they kind of get they gain value from several of these features you get and variations on the features. That makes it almost impossible to discern exactly who's more important, and it does not prioritize the real weight, let's say, in a very simple term, of the significance of these features you're analyzing. So this is one thing you need to do. And as I told you, to reduce this kind of complexity and to allow the algorithm to work properly, you also do some weighting. So you try to balance the classes, assigning weights. It's like, trying just to make them weight all equally. If you are familiar with machine learning, and I think you are, this could help really much, let's say. It's not the only way in which you could work with that, of course, but it's very common. And depth, I told you, really keep in mind that you can control it. It's one of the best things you need to take care of. Let's say best features you need to take care of when it comes to decision trees. So it might change a lot. And also this is very variable depending on the number of the elements we're analyzing. Features, sorry. There's not much variety when it comes to terminology here. Anyway, potential use case that I'm presenting to you today is a self-tracking. So I'm not going to run the whole Colab notebook, but nevertheless, I will try to be focusing on the important parts. You will have access to those outputs, so feel free to do that. I try to keep them really simple and easy. And for the occasion, I kind of generated a data set which resembles a bit the reality. I mean, a fictional data set, which contains the records of behavioral habits actually that are mine, pretty much characteristics. So I love micromanagement. I mean, I really like to test different focusing techniques and try to handle the best and to get the best of the time I spend working. So I'm kind of not obsessed, but I'm really into testing different focusing techniques. And my idea was like trying to build a decision tree to get some insights about some focusing techniques which resemble my real ones. So the data set, which is done me, was just generated on Python. So it's very weird to use something which is created in Silica, but still it includes variables that could have been recording. So I thought about that as a real world case. So it should more or less unfold in that way. Although, there's no correlation. I just checked among the variables, and of course it's completely randomized. Well, this implies other things when it comes to interpretation. Well, you will see. And the most important thing today is just like, we are going to fail. What you're not going to find in any other of these tutorials is that instead of having 4 or 5 variables with 5, 6, or even 3, doesn't matter, level of complexity, depth, literally, well, today we're going to fail because you will find so many examples online that are highly successful with very non-real-like data sets that I think you can easily handle to understand how it works, even without me explaining to you how this is possible, literally. So just last dot I want to add is just like the occurring variables, and categories are deep work. So almost hyper-focusing on a single task until it's done is one of the focusing techniques I designated. Task batching, so doing all this, several tasks all together if they are similar. Eat a frog, just like get everything prioritized depending on the difficulty. And Zen to Dawn, just do it. So these are the focusing techniques, and now it's Python time. So I will just jump out of this presentation and go here. So you should see my nice Colab, and of course, I hope it's not, I really try to make it very basic, in a very basic fashion, and utilizing using any kind of variables which had high representation in any other tutorial. So forgive me if it's too simple, maybe. And I hope you like the cats anyway. Sorry, that's a secret feature of the of Colab. If you want to know that, just ask me later on. I will show you how to put it on work. Anyway, so we need a lot of modules, and that was my choice, let's say, because I really wanted to try and stay on scikit-learn. The first thing you normally do is just like loading modules and then locate the data set and read it. And now I hosted it on my GitHub, but it's going to be on Women in AI GitHub, so it will be available to you. And what I tried to do was just like preview my data set. I just added 10 entries here. So you can see that this is the nature of the data set we are looking at. So I just picked out the day, the focus technique, one of the, among the ones that I described to you before, a location, so coffee shop, outdoors, library, home, or eventually office. Task type, note-taking for writing coding. So task duration in minutes, poses duration in minutes, motivation, yeah. In truth, as I told you, this really resembles what I've been trying to record for myself, but I didn't really have enough records to work with, so I just generated it. I could have been amplifying the ones that I had probably to make it more real, but yeah, that could be another, homework. Anyway, so what we have here, with Profiler Report, this is a very nice tool, but it was originally, it was with pandas. I'm not sure if it's there anymore. I had to change the command because it was like, yeah, epsilon data profiling, import Profiler Report. I was so shocked. Anyway, I placed here the link. Before it was with pandas, but they changed it. What does it do? It allows you to get all the stats about your variables without just spending time learning ggplot, or sorry, plotly here in this case, or any sort of other module, which could be useful with Python. So you can see that we have like aggregated statistics for whatever. This is highly recommended even if you just need to show stuff regarding anything. So if it's just for you to analyze or just to show and get a very kind of macroscopic glimpse about your own data set, that's perfect. So what I discovered was just like, no correlation, of course, we were expecting that, so it's random, but that there were some imbalances. Of course, this really depends on the feature, the target feature you're kind of prioritizing and the rest of them. So you have to think classification, let's say, when it comes to this kind of trees, okay? So what you do when you have the stats, you just like to do one important step that you might know about, which is convert categoricals into numbers, which is a very tough choice. And there has been actually a discipline built upon that, which was called numerical taxonomy, and emerged in the 60s, if I'm not wrong. Anyway, I studied it just because I was into botany. And it was really fascinating because they were trying to approach what we call now one-hot encoding, just to convert in different, to convert the categoricals into numbers, kind of preserving their meaning. Anyway, this is one option to work with this kind of data set. So what I did was just like using the same basic thing you might want to use with any machine learning method. So just like drop my selected feature, my target feature, the focus technique, and of course kept all the rest as features, generate features to predict the outcomes. And then I got the dummies. That's an option, exactly as I told you for the one-hot encoding, but there are other ways to label literally the categoricals. And I suggest you not to do this one because it doesn't really work as I want to. So that's what you get. So if we look at the previous one, you just have, for example, the days is just like a 0 for no, 1 for yeah, that's it. So it becomes really binary. This is useful. And we have all the 5 days of the week. If you go and check, for example, all the variables, sorry, here I can't see that. It's just like, yeah, we can really have all the days of the week and whatever, but this really prioritizes just the yes or no nature of the categorical. That's the way in which you can work with that. But you might even know more about that than me. So what you do is, again, train, test, split. So you split your data set, just one for training and the other one for testing. And then you call the classifier, which is this one. So it's pretty easy. You don't really need to know much more about specifically classification trees, unless, of course, you want to really dig into the deep problematic diversity of the trees you can handle. There's not just one tree, there are even more. But anyway, you fit the model and you predict. So what you can get, okay, it's something like this. So you recall that I told you about depth. So the number, literally, the number of levels you have in which this is the root node, which depends, the nature normally depends, and it's, of course, predicted based on the target feature you try to analyze. And you can see that we have deep work here. And then you have, of course, the rest of the decision chance nodes here. This is a 2-level. I did this mistake, sorry. So I mean like 0, 1, 2, or 3 levels, but you can regulate that depending on the depth you specify here. So if you're crazy enough to change it to 3 or more, because you will understand how it goes, this gets more complicated. Nice, huh? Colors have a meaning, if you're wondering. I will link you also the documentation for scikit-learn and decision trees, which is very well done and very straightforward. I wasn't expecting something so easy to approach. Anyway, yeah, the colors have a meaning. I'm not going to cover it here, but as I told you before, I can't really delve into that in this small amount of time, but I will be, of course, available to tell you even more about that. Nevertheless, what we have here, it gives you the glimpse, of the complexity that this thing could have. And the thing is, like, they tend to have a very bad habit when it comes to this, when it comes to modeling this kind of choices. So sometimes they tend to overfit, as I told you before, not exactly exploiting in a good way the variables. So just using uninformative variables to get their results, their decision displays. So this is crazy, but it looks very good. But don't do that. So this tells you one thing: if you end up with something like that, ask yourself that you really want to work with all the features you've been working with, or if is this the good choice when it comes to software. And you will ask me, okay, but how can you tell if it's good or bad if you don't read through the lines, what's in each one of these nice cells, so in these nodes? Well, the evaluation for this sort of things is exactly the same that you can do for any other machine learning system. So, well, you can get accuracy, F1, precision, recall, whatever you want, but it needs to be the first thing you do, and then you go back and try to interpret, because look at the results here are embarrassing. So you understand that there is something wrong with the data set. When it comes to that, that's the thing you normally don't see when it comes to tutorials. They don't show you where you fail, but when you learn, you'll know that probably better than me, but that's the only way in which I learned, by failing. And you don't have to get discouraged by that, because it tends to be the way in which you learn. And the more you fail, the more you get good at something. So don't be afraid of that. Going backwards, let's see a couple of the features if you want, just to get a glimpse of what's contained and how you should interpret what's inside the cells. So let me just like add, okay, let's put it back to 2, okay. Again, so this is a very specific type of tree, and normally it should tell you, for example, in the root node, what was the choice, the main value that had guided the classification. So in this case, the high motivation, which should be less in this case of 0.5. Why? What's high? Well, actually classified the focus level or motivation in high, medium, and low. So here it doesn't really make sense, because we had to convert it, in terms of numbers. If I had that worked out, maybe as 1, 2, 3 would have been better, although you really need to take into account the significance of each one of the features you're considering. This is a highly interpretive work. It's not like other models, which still require you to interpret a lot. But before you start using them to predict something, well, this one is very tricky. Doesn't matter. Genie here, I don't know how it's pronounced because I always seen that, but I don't know. Anyway, it's an index of purity. So if it's major, if the number of you have here for this score is major than 0, normally means like that this pertains to a multi-class. And well, I really don't want to go in the detail of that, but it's a good indicator when you're trying to prune and to work with the nodes, let's say the chance nodes, or if you're trying to simplify what you're looking at. So don't expect really to stay and spend your time 5 minutes on your tree unless it's pretty easy. If you go and see, for example, one of the traditional datasets like the versicolor or the iris, dataset, well, I always speak about plants, that normally helps you a lot when this kind of task, because that's perfect to get classified. Trust me, I would suggest to do that. Just copy and paste whatever you have here, adapt it, and try with that, and then go back and see what it dismiss, please, because you understand how it works. Anyway, the indication of the class you're looking at normally, the one which represents your target feature is the work here. So we're still looking at focusing methods or techniques in this case. I'm not going to interpret that, but I can let you know that normally if it's, this should be a decision. So it should be a no and a yes, depending on the first line or the motivation of the choice, which is always stated first. Okay, samples just refers to the fact that you're started with the 100% of the data set. You can have even the number of records instead of the percentage, which is even better sometimes. And then you have the value that fit into this prediction normally. So you will see the percentage over the data set that fit here. Well, then it gets really crazy and you don't understand what you're looking at. But as I told you, my purpose was not to show you a success story and just like trying to model something which is not even real, but just trying to understand how this could work. I don't know if I'm still in time actually, but yeah. Okay, perfect. No, I'm kind of out of time, but yeah, okay, perfect. So that's conclusive remark indeed. So just letting you know a couple of things. So they work with simple data. If you want to handle complexity, else you need to start reading into books. I can suggest you a lot of books, and depending on when it comes to your problem, I can really try and help you. I handle mostly biodiversity data, but I understand also very much how you should work with categorical variables, just because I'm more now, for various reasons, I'm just more into this kind of things. And then, yeah, basically experiment with anything you're familiar with, and really real world like data set bite a lot, but not give up. Please do not give up. Just try and keep it running. That's the way in which you learn. That's it. Thank you. I hope it was in time because we started some minutes late, but I didn't want to kind of annoy you. Anyway, if we still have some time for questions and whatever, I'm here.